More generally, when the float is defined by multiple boundaries, it is a good habit to follow these steps. Sorting the imported data. First of all, sorting the imported boundaries into different folders corresponding to the future solids may make this task easier as soon as they are numerous. Then, let us create a float folder first, in which all the float solids will be located. And then, let's create a port side half hull subfolder, another one for the port side rudder, and a last one for the port side keel. Finally, let's transfer the imported boundaries in their target folders. Symmetrizing the half model. If necessary, the imported boundaries can be mirrored in order to include all the boundaries needed for building a watertight solid. In our case, only the half hull boundaries have to be mirrored, as the appendages will be directly mirrored as solids. Let us therefore activate the folder in which the boundaries will be mirrored, and then select Transform, Resize Shift Scale in the menu bar or in the browser's pop-up menu. A dialog box then pops up for inputting the transformation data. In our case, we will simply enter a -1 coefficient in the while scaling ratio field. Don't forget to tick the Keep Reference Items option in order to conserve the original boundaries. As soon as the boundaries are mirrored, their folder can also be renamed. Building a watertight solid. Let us open the hydrostatic viewport in order to watch the curve of areas which will appear as soon as the solid will be created. In order to create the hull solid, let us activate its parent folder first. And select Solid Join in the menu bar. Then let us select the hull boundaries using the Ctrl and Shift keys, or simply by clicking on their parent folder. Let us check the current selection on the 3D viewports and hit Enter to validate. A dialog box then pops up for controlling and setting boundaries size if necessary, so that no red dry face can be seen from outside. This control allows ensuring that the hydrostatic pressure applies everywhere, from the green external side to the red internal side. Double-clicking on the reversed boundaries immediately toggles them if necessary. As soon as all solid boundaries are green, they can be validated and a green curve of areas appears in the hydrostatic viewport. The created solid can then be renamed. The display menu's Show Face Orientation option allows controlling boundaries sides as soon as necessary. Moreover, the Set Solid Faces function allows setting the solid's boundary sides whenever necessary. Let us now create a port side rudder similarly. The green curve of areas will immediately reflect the port side rudder's incidence. Let us now create the port side keel solid. The green curve of areas will reflect the keel solid's incidence similarly. Symmetrizing solids. We have only created the port side appendages in order to create directly all the starboard appendages by symmetry. Let us therefore select Transform Mirror in the menu bar, and then click on the solid to mirror. As previously, the curve of areas will reflect this transformation in real time. Finally, let us rename the mirrored solids. All the ship buoyancy descriptors are now present in the current folder.